Good morning, everyone. Welcome. Good morning, everyone. Welcome. All right. Let me just call everyone. All right. So, good morning, everyone, and let's start the session. All your friends are going to join up. Yes, Ria, good morning. Okay. So, basically, see, this session was, I had not informed you about this session because usually the Wi-Fi is not working and I want to upload the usually I want to upload the session, right? Not go live, but this time everything is fine. So I just thought I'll call you up in the live class only. Okay, so yes, chalo, let's begin our session. Everyone will join when they will know about the session. Okay, chalo. All right, so basically we are going to do some name reaction revision once again. This is a revision series that we are doing. And yes, guys, for those who will see this session later on, okay, there are two batches which are going on already. This is a detailed batch and this is a practice batch which is going on. All right, and for those who have not yet subscribed and who still want to subscribe, who had missed this offer, it has been extended on popular demand till 29th of July. Okay, so this offer till 29th of July, you can join Unacademy Plus in practice batch as well as the detail batch. And by using the same code Jagriti S Live, you are going to get 20% off. All right. This is the code Jagriti S Live. Okay, that gives you a 20% off, not a 10% off till 29th of July. Okay, very well. Now we are going to start our discussion, everyone, and all of you already know that a battle of coal free classes are already going on Unacademy. And right now we are practicing on bioinorganic. After that, we will start carbohydrates and amino acids. Okay. And if you already haven't joined the group, please do CSIR-NET 2022. Alright, this is the Telegram group. Yes. Alright, good morning guys. Good morning everyone. Okay, chalo. Let's start. Let's start our discussion guys. So what is the first reaction that we are going to discuss? We are going to discuss the Bayless-Hillman reaction today. Alright, and many other reactions. But first of all, let's start with the Bayless-Hillman reaction. This is another important reaction. I hope that you have already studied this reaction. Okay, and if you are having any questions, you can also ask regarding any of the reaction. If you want me to do any reaction, you can tell me so, right? कि आपको कोई reaction नहीं आ रहा है, वो भी हम कर लेंगे, ठीक है? So let's first talk about the Bayless-Hillman reaction. So what is this reaction, guys? Basically, in your molecule, you are having an aldehyde, let's say, plus an alpha beta unsaturated ester molecule. Alright. So this in the presence of a strong base. Now a strong base which can also work as a nucleophile sometimes. So that is DABCO. We are taking a strong sterically hindered base. Okay. And that is going to give you a product like this. That is on the alpha position. This is the alpha position. It is just like an aldol reaction, but it is taking place just like an aldol reaction, but it is taking place from the alpha position of a alpha beta unsaturated ester. Okay, so you are just going to get the alcohol and the R group. Alright, so what is this, guys? You just got a condensation product from the alpha beta unsaturated ester and the aldehyde. Okay, what is this molecule? What do we call this molecule? It is alpha. देखो अल्फा पोजीशन ये हो गया तो विल काउंट बीटा दिस वन सो बीटा हाइड्रोक्सी अल्फा पे क्या है एल्कीन ग्रुप है तो अल्फा एल्कीनाइल बीटा हाइड्रोक्सी एस्टर okay we will call it alpha alkenyl beta hydroxy ester. This is your product of the Bayless-Hillman reaction. ठीक है what is DABCO? DABCO is a strong base like this. Okay, this is your strong base DABCO. Alright, now what happens is sometimes your DABCO is also written in this way. Okay, DABCO is sometimes also written in this way, but it is the same thing. ऐसे, right? But it is the same thing. Alright, so let's consider the mechanism, what is going on over here. So basically, alpha beta unsaturated ester, how is it going to react? First of all, the DABCO molecule is going to attack over this carbonyl in this way. Alright, it is going to attack on this molecule in such a way कि ये वाला जो carbon है, it's going to form an enolate like intermediate. Okay, so alright, so this carbon is where it attaches to, and this carbon is going to form the enolate like intermediate O minus OET in such a way. And what else do you expect? Now see, the connectivity was built on the alpha carbon, so the molecule is going to connect from the alpha carbon only. Okay, in this way, ऐसे करके. So what are we utilizing? what concept are we utilizing? We are utilizing the concept of enolate only. We are still using the enolate chemistry only. Just that, yes, good morning who are joining now. So just that here from the alpha beta unsaturated ester you are creating an enolate and that enolate you are using. Okay, so you're not using a simple enolate that is from a simple carbonyl, you're removing a proton. It's not like that. It's the enolate intermediate only, but from the alpha beta unsaturated ester. And how do you generate that? By providing a nucleophile to it, by causing 1,4 addition on the alpha beta unsaturated ester. Okay, so now the molecule is in this way, right? So this Dabco molecule has attacked on the fourth position, right? It has given a conjugate attack, and because of that, and because of that, you have this kind of a molecule. All right. Now, what is going to happen next? What have you got? You have got alpha beta. You have got beta hydroxy ester already, isn't it? You have already got the beta hydroxy ester. Now, what is going to happen, guys? You can undergo, let's say, let's keep this O minus only because we have not done the aqueous workup, right? So after this step, let me just write in the next slide. After this step, what is going to happen? This is your O minus, one carbonyl over here, OET. The alpha position, beta position, you have got this, and on this beta position, you have got the DAPCO molecule attached. Okay, now what is going to happen? What is supposed to happen? This proton, which is acidic, why is it acidic? Because there is a ester over here. So this proton is acidic. This will be lost, and the proton is gained by this molecule, this O minus over here. You once again get the enolate type intermediate in this way. And you know, the loss of this proton is very important because then only you are able to proceed with the mechanism, right? So this O minus is going to fall back and the DAPCO molecule is removed. Okay, and guys, throughout the mechanism you are having a positive charge on this nitrogen after it has formed a bond over here. Okay, because obviously it has attacked from the lone pair, so lone pairs are used, and that is why you're going to have this kind of a system. Yes, good morning guys who are joining now. So basically I did not inform you about this class because I was checking my Wi-Fi and everything once it was live, and then I informed you. Okay, so yes, chalo. Alright, good morning. We have started with Bayless Hillman reaction today. And if there is any reaction that you want to revise with me today, please tell me in the comment section. We will discuss that reaction also. Okay, chalo. So very simple Bayless-Hillman reaction, that is using the aldehyde and alpha beta unsaturated ester. You are going to get the alpha alkenyl beta hydroxy ester. Okay. Yes. So this is the mechanism, and we are done with the mechanism almost. ये देखो डबल बॉन्ड इज फॉर्म. दिस इज अल्फा एल्कीनाइल, क्योंकि यहाँ पे क्या है, एल्कीन है. अल्फा एल्कीनाइल एंड देन बीटा हाइड्रोक्सी एस्टर. ऑलराइट, सो दिस पार्ट इज द एल्डोल कंडेंसेशन सिंपली. और ये जो अल्फा एल्कीनाइल है, दिस इज द एक्स्ट्रा एफर्ट दैट द डैब्को इज डूइंग ऑन द अल्फा बीटा अनसैचुरेटेड मॉलिक्यूल. So in this reaction, the overall reaction, you are using the enolate chemistry only, but the enolate is not formed. Very important guys. जैसे कि normal aldol reaction करवाते हैं हम लोग, ठीक है. तो ये carbonyl है, carbonyl का एक proton remove कर दिया. This is how you get the enolate O minus, ठीक है. And this is going to attack over another molecule of the aldehyde. You simply get beta hydroxy ester, is it, या फिर beta hydroxy let's say this is carbonyl ketone. ये देखो, this is what you get in the simple aldol condensation reaction. Yes, अभी ये simple aldol तो है नहीं, you are still using the enolate though. ये देखो इनोलेट बन रहा है बट फ्रॉम द अल्फा बीटा अनसैचुरेटेड एस्टर. लुक एट दिस. ओके, एंड दैट इज व्हाई व्हेनेवर द इनोलेट विल अटैक समबडी इट इज ऑलवेज गोइंग टू डू सो फ्रॉम द अल्फा पोजीशन. इसीलिए अल्फा पे कनेक्टिविटी है यहाँ पे. ओके, नॉट ऑन द बीटा. All right, so this is what we have to understand. Okay, just a second. Chalo, let's move onwards. All right, so this was Bayless Hillman reaction. Now, if you see some other electron withdrawing group, let's say electron withdrawing group जो यहाँ पे लगा हुआ है, let's say there is an ester group over here. ठीक है, let's say there is an ester group over here. Now, if you don't have the ester, what else could you have? और क्या क्या कॉम्बिनेशन पॉसिबल है देखो. R1 डबल बॉन्ड R2 और यहाँ पे भी क्या क्या कॉम्बिनेशन पॉसिबल है. आइदर यू कैन हैव लेट्स से दिस इज एन X, तो यहाँ पे कार्बोनिल हो सकता है ऑक्सीजन. यस, यस सुरेंद्र, क्या फीस है ऐप पर नेट की प्रिपरेशन करने की? ओके, एक्चुअली फीस इज डिफरेंट. इफ यू जस्ट ओपन अप द ऐप यू विल नो. और अभी फिलहाल के लिए जो ऑफर चल रहा था, वंस अगेन इन्फॉर्मिंग यू ऑल, कि जो ऑफर चल रहा था 20% ऑफ वाला, ठीक है, वो अभी 29 जुलाई तक एक्सटेंड हो गया है. So you can still avail this offer and get 20% discount. Usually 10% discount you get. अभी 20% वाला ऑफर चल रहा है by using this code Jagriti S Live. ठीक है, तो आपकी जो भी फीस है वो 20% उसमें कम हो जाएगी in your Unacademy Plus and Iconic both subscriptions. Okay, and you can convert them into EMIs also. So आप ऐप पर एक बार चेक कर लीजिए कि 20% ऑफ लगा के कितना एक्चुअल प्राइस आएगा. ओके, द ऐप इज गोइंग टू टेल यू द पार्ट कैलकुलेट करके. ठीक है, all right, so there is some electron withdrawing group which is required. So what can be the electron withdrawing group? अभी अभी देखा हमने, it could be ester, yes, it could be CHO aldehyde, it could also be a cyanide guys, and if it is cyanide it will be difficult to identify, but dabco या फिर big base समझ के आप समझ जाना. It could also be a sulfonyl group like the sulfone group basically. It could also be a sulfonic acid group like this या फिर sulfonate group. ठीक है, it could also be an amide and it could also be a phosphide. देखो ये तो बिल्कुल ही प्रेडिक्टेड नहीं है गाइज, अगर आ गया तो पहचान लेना इसको. That is, the molecule will actually look like this, isn't it? Yes. So on the alpha position, if you are having connectivity, let's say you are having a carbonyl. Okay, let's say हमारे पास aldehyde है, let's say CH3CHO. ठीक है, and I have this molecule. इनका product कैसा दिखेगा? This alpha carbon must connect or onto the aldehyde carbon and the aldehyde becomes an alcohol. Okay, this is how the product is supposed to be of the Bayless-Hillman reaction between these two substrates. ठीक है, so it is important to recognize a reaction, very very important. All right, ये Bayless-Hillman reaction ही है, nothing else. All right. Yes. Any more reaction guys that you want to study? We will be doing Bamford-Stevens reaction. ठीक है, चलो एक और बहुत important reaction है, that is Bamford-Stevens reaction. That is what we are going to study. Okay, and we will do some really important example of this क्योंकि ये बहुत twisted तरीके से आता है. ठीक है, so let's discuss Bamford-Stevens. बहुत easy है वैसे तो. Now, formation of alkene by base catalyzed decomposition of hydrazone, tosyl hydrazone. ठीक है? So let's say, ठीक है, let's say for example ये tosyl hydrazone, ठीक है, some tosyl hydrazone. So there are two different reactions possible from the same substrate. आपको पता है Bamford Stevens possible है, Shapiro भी possible है, ठीक है. So depending on which type of base we are using, let's say we are using a sodium methoxide या ethoxide base, ठीक है, and we are heating the mixture in the presence of glycerol या glycol, ठीक है. What is supposed to happen? This tosyl group is going to leave, ठीक है, और यहाँ बन जाएगा एक alkene in this way. Alright, so you're going to get an alkene over here. Now, how is the mechanism going through? Let's see that. इसका mechanism कैसे है? First of all, when you are removing the proton from the base, now what is the base, guys? ये NaOMe base जो है, is it a very strong base? Not a very strong base, not like butyl lithium, ठीक है. So ये क्या करेगा? It is going to remove the proton. Let's say first of all we want to remove a proton. Which proton will be removed? The most acidic one, which is lying on the nitrogen, that will be removed, ठीक है. Let's consider that possibility. N minus. Let's say I have considered N minus. What is this N minus going to do now? ये क्या करेगा N minus? Right? It is just going to eliminate the tosyl. Either you can write like this or you can also write like this. The tosyl is going to be removed. Once the tosyl is removed, you have something like this minus और यहाँ पे positive charge. ठीक है? What does it do? ये देखो tosyl remove हो गया यहाँ से. What does it do then? It will want to break apart. ठीक है, अब ये जो intermediate है guys, depending on two different solvents, this intermediate is going to break down. ठीक है, what is that? Let's say you have taken this in a protic solvent, in a polar protic solvent, ठीक है, तो क्या follow करेगा? Ionic mechanism follow करेगा. Okay, so let's take it into a different slide. We were talking about CHR and one more carbon, there was one more R group and double bond N and double bond N minus, ठीक है. So depending on the solvent, let's say polar solvent में ले रहे हैं, क्या फर्क पड़ता है guys? In the polar solvent you have followed ionic mechanism. Yes, in the polar solvent you follow the ionic mechanism. So ionic mechanism के लिए, see what will happen in the ionic mechanism? The nitrogen will try to eliminate. Alright, the nitrogen will try to eliminate and ये carbon के ऊपर negative charge आएगा. See, this is what you have. Carbon has a negative charge. So since it is a polar solvent, let's say ethanol or let's say some solvent where you have a source of a proton. ठीक है? Some solvent having a proton. Okay? So this proton is grabbed by this carbon. What is going to happen? You will just get a carbanion, nothing else. In the polar solvent, the point is in the polar solvent you will just get a carbanion. Okay? And now the nitrogen is going to eliminate. What happens next, guys? Nitrogen eliminates, you are going to get a positive charge. ये देखो एक hydrogen है यहाँ पे and you have got a positive charge on this carbon. What will happen? Proton falls off to the medium. Yes, basic medium है already. So it is going to give you this simple alkene. The reaction mechanism is very simple over here. Okay, you are just getting an alkene from a tosyl hydrazone in the presence of sodium methoxide. In the polar solvent, Yes, in the polar solvent only कार्बाइनाइन forms. क्योंकि कार्बिन क्यों नहीं बनेगा? बिकॉज जैसे इलेक्ट्रॉन डेंसिटी कार्बन पे आई वैसे ही प्रोटॉन ले लिया. ठीक है, सो दैट इज वाई कार्बन नॉट फॉर्म. लेकिन अगर हम नॉन पोलर सॉल्वेंट लेते हैं, लेट्स से वी आर टेकिंग अ नॉन पोलर सॉल्वेंट. नॉन पोलर सॉल्वेंट में देर इज नो पॉसिबिलिटी of getting a proton. So what will happen? Let's say we consider from this carbanion that nobody is giving the carbanion a proton. अगर प्रोटॉन कोई नहीं दे रहा है तो क्या होगा? It will form a carbene. Nitrogen will eliminate minus N2. It will form a carbene in this way. Yes. And what is that carbene going to do, guys? ये देखो carbene जैसे देखो CH insertion करती है ना carbene, ये वैसे ही करने वाला है. This hydrogen falls on the carbene. Okay. And you are going to get this kind of a molecule. ये हाइड्रोजन इधर आ जाएगा. ठीक है, so you are going to get this kind of a molecule after the hydrogen bond falls on the carbene. All right, so this is your molecule. Now can you guarantee कि कौन सा product बनने वाला है? No, you are always going to get a mixture of alkenes, isn't it? Because this reaction is not stereo specific, you're always going to get mixture of alkene. क्योंकि ये देखो यहाँ पे क्या हो रहा है, the minus charge is right over here, the proton can fall this step. Is it very stereo specific? Not at all. It is not at all stereo specific. You might get a little bit of more stable trans product, but ये stereo specific तो नहीं है. It is just going to rearrange and give you the product. ठीक है, so two different cis and trans mixture are possible. ठीक है, now we are going to consider a very important example of Bamford-Stevens reaction. ये देखो, अच्छा just a second. So in this phase a molecule and I'm just heating it, nothing else. What does it give you guys? Just heating. Yes, I have also not given you any solvent. No solvent. Or let's say not a polar solvent, I'm only giving you toluene. Not a polar solvent. Yeah, try to draw the products. Done? So only in the presence of heat, what are we going to do first of all? What should be our first step? That this aziridine ring we are going to break down first of all. Yes or no? Can we break this ring? Yes. So guys, how are we going to break this ring? See, it is not your usual aziridine. Why? Because यहाँ से nitrogen elimination की possibility है. Usual aziridine कैसे break होता है? Let's say we have this aziridine ring. How does the conrotatory ring opening take place? The bond is going to fall over here. All right. ये यहाँ से खुल के इधर आ जाएगा. ऐसे करके. Yes. So normally your aziridine will open up to give you azomethine ylide. ये azomethine ylide जैसा ही है. ठीक है. But I am not going to open this ring in this way. Why? Because there is a possibility of the nitrogen leaving. So I am not going to open it like this. Let's consider another possibility, guys. क्या possibility हो सकती है? That is, I can break the ring in such a way that I get this molecule. Yes, you get a nitrogen and the alkene. Alkene is eliminated in such a way. Now what about this nitrene, guys? This bond falls over here और ये electron density यहाँ पे आनी पड़ेगी. So ultimately you are just going to get nitrogen elimination throughout this whole reaction. ठीक है, ये पूरा रिएक्शन हो भी जाएगा तो भी क्या होगा जब नाइट्रोजन एलिमिनेट होगा यहाँ से you are going to get this carbon as a carbene because toluene solvent है. That is all you need to know about this. सिर्फ यहाँ पे carbene मिलेगा आपको and then only one side you are having a hydrogen. So this is what you get. ठीक है, this is your product. Now which product is major product, E or Z? Only depending, see, since this is not a stereospecific reaction, you cannot have very, 100% one product, but because the E alkene is more stable, the molecule can rearrange itself in such a way before losing this proton, right, that you are going to get the greater amount of E alkene. So 90:10 is the ratio. ठीक है, 90:10 मतलब कि 90% आपका E alkene है and only 10% is the less stable V alkene. Alright, now we move onwards and we see one more example of selectivity. ये देखो, selectivity का example, that is, let's say you are having this molecule tetrahydrofuran, third position पे क्या है, tosyl hydrazone NHTS, and you are having tertiary butoxide base and tertiary butanol. Both of these are strong base combination, right? Alright, just a second. Alright guys, so can you see this? Yes, right? ओके चलो आ जाओ फिर, लेट्स सॉल्व दिस। तो बेसिकली दिस इज टेट्राहाइड्रोफ्यूरान, और ये देखो कहाँ पे, थर्ड पोजीशन पे टॉसाइल हाइड्रोजोन है। So what are we doing in the presence of sodium methoxide? We are heating this. Okay. So what should be the major product? Done? Yes. So what is going to be the major product, guys? टू पोजीशन की साइड में देखो, एक तो ये प्रोडक्ट हो गया योगेश, दिस एंड दिस। ऑल राइट, राइट। नाउ सी व्हाट इज, हु इज द मेजर प्रोडक्ट, दिस वन, ये वाला मेजर प्रोडक्ट है। व्हाई? because it can have resonance, it is resonance stabilized। ठीक है, दूसरा वाला जो product है, right, this one there is no resonance possible, so this is only a minor product, right? So if this is 75%, this is only 5% of the product। Okay, and you can do the reaction mechanism by yourself, I have only given you sodium methoxide and heat। ठीक है, let's say the solvent is not mentioned, फॉर एग्जाम्पल लेट्स से द सॉल्वेंट इज नॉट मेंशन, तो आप क्या करोगे? मैकेनिज्म सेम है, प्रोडक्ट विल आल्सो बी द सेम, जस्ट द व्हाट इज फॉर्मिंग कार्बा एनायन और कार्बीन, ओनली दैट इज द डिफरेंस, बाकी एवरीथिंग इज द सेम, राइट? सो यू आर जस्ट गोइंग टू फॉलो this step, that this proton is removed from here, what will happen, ये नाइट्रोजन यहाँ से टॉसाइल को हटा देगा, all right, it will have a negative charge। All right, followed by this, let's say when the solvent is not mentioned, you are going to consider कि non-polar solvent है। ठीक है, तो इसको ना कार्बीन बना दो फिर in this way, minus N2 directly I am doing, just skipped one step। all right, ये इधर fall करेगा तो ऐसे fall करके निकल जाएगा, right? just form the carbene। now there are two types of hydrogens, one over here, another over here, which hydrogen will be lost? definitely guys, the product is going to form in such a way that you are getting the more stable one, more stable product। ठीक है, so इसीलिए ये आपका major product है after the hydrogen rearrangement। this is your major product। okay, so guys we are going to do one more reaction which is very important। ठीक है, इसका नाम है Appel reaction। okay, why is it important? because इसके भी दो applications है। ठीक है, Appel reaction, the reagent is very very important and it might also confuse you sometimes because the same reagent is used in various reactions। ठीक है, we have already used the phosphine and this combination in the Mitsunobu reaction we have done in the previous session। ठीक है, let's say ये R dash है। alright, you have a hydrogen over here and you have a OH group above the plane, for example। ठीक है, So you are taking CBr4, let's say, and PPH3. ये combination आप ले रहे हो. What is going to happen? This OH is removed, hydrogen comes above, and Br goes below. So what is this? It is also an SN2 reaction, just like the Mitsunobu reaction. Okay? But what just happened? You are getting the SN2 by the bromide, not by the OH. Okay? So the nucleophile is your halogen. Halide formation, yes. Mechanism is very simple. You just have to take care, guys, कि यहाँ पे ये जो combination है CBr4 and phosphine, what is it doing? How it is going to form the reagent which is going to react? कैसे form करेगा? That is important. So first of all, the phosphine is going to attack on this carbon. It will form CBr3 single bond PPH3. Now there is a positive charge on this phosphorus, so एक Br minus free भी है यहाँ से. That Br minus is going to grab a. Alright, just a second, थोड़ा सा change है mechanism में. Yes, yes. Let's open this and write. Okay. So first of all, this phosphine is going to attack the bromine in such a way you get a CBr3 minus. Why? Because minus is possible on this carbon. ये हो गया यहाँ पे positive charge. Now this minus is going to attack over phosphorus and Br minus eliminates. You have PPH3 connected to CBr3 now. Okay, phosphorus still has a positive charge and there is one Br minus which is free. It is going to take away a bromine and it is going to basically form a ylide like this. ये बन गया ylide. ठीक है? Now this ylide is going to react over here. Usually this is what happens. अच्छा, just a second guys. ये mechanism हमारा carbonyl के लिए use आएगा. If you are having the carbonyl. Yes, that is when you are having the acid, for example. Yes, yes. Not for the alcohol. Alcohol के लिए slight difference है. Yes, yes. Alcohol will attack and phosphorus is going to make the OH a good leaving group. Okay, yes. Yes, because basically the work of phosphine over here is to make the OH a good leaving group. तो ये phosphorus जाके OH से attack OH पे attach होगा, ठीक है? So what is this CBr3 minus doing? It could have attacked on this, but यहाँ पे इसको acidic proton मिल गया, ठीक है? So in this reaction combination, it got the acidic proton, so it's not going to go and attack back on the phosphorus. So after it gets the acidic proton, ये बन गया O minus, you have a hydrogen. Why did this happen? Why is it not attacking the phosphorus? Because in the absence of a proton, that will happen. Acid-base reaction is taking place faster. तो ये O minus बन गया. Now what is this O minus going to do? ऑक्सीजन हैज अ ग्रेट एफिनिटी फॉर फॉस्फोरस, इसको दिख रहा है यहाँ पे फॉस्फोरस पे पॉजिटिव चार्ज है, so it is going to attack on the phosphorus and Br minus is going to eliminate, right? This becomes oxygen phosphorus bond PPH3 like this. One hydrogen is still below. Now what is going to happen? एक यहाँ से halogen free हो गया. This halogen has become free. Br minus. This Br minus has become free. It is going to do SN2 attack over here. It is going to remove this oxygen which goes with the phosphorus. ठीक है, and it's going to give you the SN2 attack like this. Backside attack. और कौन eliminate हो गया? Phosphine oxide. Yes, the phosphine oxide got eliminated. So this is the basic reaction, Apple reaction, the same combination. This same combination is used in plenty of other reaction, guys. जैसे कि वो हमने बना दिया था अभी, that was useful for Core-Fuchs reaction, right? And here the use of phosphine is just to make the OH a good leaving group. ठीक है, इसलिए ये important है दोनों चीज ये याद रखना कि किसके लिए यूज हो रहा है, in what context. So we'll see an example, guys, कि if you have this kind of a molecule, let's say, question might be asked like this, जैसे कि carbohydrate molecule दे देते हैं. There are plenty of reactions of carbohydrate molecule. Why? Because there are so many OH over here. ठीक है. So there are so many alcoholic groups. Let's say I've protected all the other ones और ये जो anomeric OH है, only this remains. Okay, and then I'm providing PPH3 and CBr4. Same combination I'm providing, alright, along with DMF and heat. So DMF is not a, reagent over here, it is only a solvent. DMF का कोई काम नहीं है. What is it doing? Only a solvent. PPH3 and CBr3 are going to basically react. Now there is an OH above. अब इसमें product क्या बनेगा, guys? All the other alcohols are protected, so they are not going to react. Who is reacting? Only this free OH. This free OH is reacting, so the free OH is first of all going to become OPPH3. It's becoming a good leaving group. यहाँ पे, yes, यहाँ पे as it is OH leave कर जाएगा and the Br is going to add over here on the axial position. So OH was equatorial. Equatorial से axial चला गया. Does it make sense? From below, yes, Shushmita, absolutely. So if the Br minus attacks from below, when the oxygen has become a good leaving group with the phosphorus, तो ये क्या हो जाएगा? Inversion. This is also inversion with respect to the anomeric carbon, right? So guys, there are plenty of reactions. ठीक है, बहुत बार बहुत अलग अलग टाइप के क्वेश्चन आते हैं फॉर दिस पर्टिकुलर एनोमेरिक OH. लेकिन अगर ये कॉम्बिनेशन दे दिया तो यू आर 100% श्योर कि इन्वर्शन हो रहा है. देयर इज नो NGP, नथिंग इज हैपनिंग ओवर हियर, right? Only inversion, only simply inversion. Yes. See, अब मैं ये question पूछूं कि ऐसे भी तो हो सकता है ना. Let's clear the confusion over here only. ये देखो OPPH3 ये बन गया good leaving group, right? So this anomeric OH, it can give the electron density and it can generate a carbocation like this, ऐसे करके, right? And then the Br minus can attack. Then also it's going to give the same product, but ऐसा हो नहीं रहा है. This is not taking place. Okay, it is a direct SN2 reaction. Alright, it is a direct SN2 reaction which is just removing the OH from here and Br minus attack from below. Okay, so this is the major product. Now, one more very important reaction there is. I want you all to try this out, guys. बहुत अच्छा example है ये. Alright, so what will happen? See, I'm also giving you the product over here. You just have to draw the mechanism. So you have CCl4, triphenylphosphine, and triethylamine. You have an amine also over here. Dichloromethane reflux. The product is also provided. Okay, so you are having a 5-member ring over here and the phenyl group is as it is. Alright guys, so yes, what can we do about it? What is the mechanism? Yes, is it possible that this nitrogen can use its lone pair and the oxygen can attack over PPH3 directly? You get this combination, isn't it? अच्छा यहाँ ब्रोमाइड नहीं है, यहाँ क्लोराइड है, एक ही बात है guys. So there is this chloride over here, CCl4 and PPH3. It is going to basically have the same combination. That chlorinated phosphine in this way, so 1Cl minus gets 3. अब इसके अलावा कौन है यहाँ पे? CCl3 minus. That CCl3 minus is going to remove the proton from the nitrogen. ये यहाँ पे NH group था, proton remove कर दिया, तो what you will get? You are going to get something like this. N double bond O PPH3. Yes, something like this. This is one more NHPH. इसको मैं directly PH लिख रही हूँ. Okay. This part of the molecule stays as it is. There is no role of this double bond and the ester group. Right. What is happening next? Yes. What is happening next? Can we see something? Yes, guys. What can happen? ये देखो, ये ring भी open कर सकता है. If this ring opens from this side, there will be a negative charge on this carbon. Isn't it? There will be a negative charge on this carbon. So let's say लिखते हैं हम लोग, बनाते हैं, क्या हो सकता है? In this way, negative charge on this carbon, right? So what will happen? It is going to attack on this nitrogen, bond opens up on this carbon. It is going to fall back और ये oxygen leave कर जाएगा with the phosphorus. Alright, ये bond एक बार open हुआ है, it closes back and it's going to leave. Alright, so in this way you are going to have a 5-member ring. और ये वाला जो nitrogen है, देखो first of all इतना बना दो. CO2Me, you have one nitrogen over here like this. ठीक है, so this nitrogen, there is this bond, एक कार्बन के थ्रू जा रहा है ये, ठीक है, there is this bond over here and then there is N, H and PH. Okay, ये रहा double bond यहाँ पे. Right, this nitrogen has a positive charge. So what is bound to happen? Okay, it should, this nitrogen lone pair should attack on this carbon, the bond opens up on this side, something like this, and you are going to get this kind of a molecule. So similar mechanism guys, ये azide करके ring open करके यहाँ पे attack करेगा और ये वाला जो nitrogen है ये इसके ऊपर attack कर देगा. You are going to get a 5-membered ring. Alright, something like this. ओके, सो इट इज नॉट एग्जैक्ट एप्पल रिएक्शन, यहाँ पे पूरा पूरा एग्जैक्ट एप्पल रिएक्शन हो नहीं रहा है. ओके, इट इज जस्ट द रिंग ओपनिंग. और यू कैन एक चीज और कर सकते हैं हम लोग. ये वाला कैरूथर्स में है शायद, ये वाला. सी व्हाट वी आर डूइंग इज this nitrogen could directly attack on this carbon also. This negative charge falls over here on this nitrogen. ठीक है, एक और मैकेनिज्म देख लो. ठीक है, so this nitrogen has attacked on this carbon and the negative charge falls over here. अब ये नाइट्रोजन पे नेगेटिव आ गया तो ये क्या करेगा? It is going to attack on this carbon. Okay, let me just draw the whole thing once. You will understand. ये देखो, ये वाला बॉन्ड इस नाइट्रोजन पे अटैक कर रहा है. बॉन्ड कुड ओपन अप, या फिर नाइट्रोजन पे नहीं, onto this carbon. Bond opens up. Nitrogen got negative charge. इस कार्बन के ऊपर अभी भी ये फॉस्फोरस ऑक्सीजन कनेक्टेड है. इस नाइट्रोजन से क्या हुआ? ये 3 मेंबर्ड रिंग थी, ये खुल गई यहाँ से. ओके, द रिंग हैज जस्ट ओपनड अप. दिस इज NHPH as it is. NH will nitrogen will get a positive charge. ये दो कार्बन इसके बीच में आ गए ऐसे, right? So there is a positive charge on this nitrogen because of the proton. अब ये देखो ये क्या करेगा? Negative charge falls back and oxygen is going to leave. Okay, you are going to get this molecule after the loss of this proton also. In this way also you can do. Just follow the mechanism. Very good, Yogi. Yes, ये ठीक है. ठीक है, in this way the ring can open up to form a 5-membered ring. ठीक है, ब्रेक नहीं करते हैं जायरिडीन को, ऐसे ही रिएक्ट करते हैं, क्योंकि ये रिएक्शन कैसा है? ये मैनिक रिएक्शन जैसा है. मैनिक रिएक्शन, विल्समेयर-हैक रिएक्शन का जो स्टेप है, वेयर the same kind of an intermediate is being attacked on by the aromatic ring, isn't it? ये वैसा ही mechanism है. All right, so you get the double bond over here and the oxygen is going to leave. फिर minus proton भी कर दो, minus H plus in this medium because there is a base also. So this is what you have. All right guys, so वैसे आज काफी टाइम हो गया है इस वाले क्लास के अंदर, एंड इट्स ऑलरेडी 10:30 and 10:30 is our time for the next session. So just take a screenshot of this and try to solve this by yourself as well. Very very important. This is Apple reaction का ही application है. Okay, and I'm going to now see you all in the plus classes which has started. This plus class 10:30 a.m. we are going to do acid and base today. All right, and also informing those जिन्होंने late से join किया था, this 20% offer is still extended to 29th of July. ठीक है, so if you want to join up, don't forget to use the Jagriti S live code that gives you a 20% off. All right guys, we'll see you very very soon. Bye everyone.